Hi, year 7. Good morning. Today we're talking about area of a circle. You may notice I've got some new glasses to make me look like the guy from Up, but these are to protect my eyes from the screen, so I don't need them now. Alright, let's go. We're dealing with area of circle. Here's the circle. How do I get the area? Well, if I had, so this is a radius 10 centimeters. If I just had a box of 10 centimeters, something like this, a box is 10 centimeters, what would be the area of that box? Well, it'd be 10 times 10, presuming it's a square. So that would be 100 centimeters squared. So if I put that box here, this, it would fill about a quarter of the circle, wouldn't it? So I'd have to do that 4 times if I wanted to have the circle enclosed in it, 4 boxes. Okay, so that's 4 times 100, so that's 4 times one of these 100 centimeter square boxes. It's 400 centimeters squared. But of course, there's not bits that are included, so all these bits on the outside are included in that area, and we don't want them included in the area. Now what's interesting, that instead of it being 4 boxes big, it's actually 3.1415925 on forever boxes big. It's not 4, it's not 3 boxes big, but it's actually 3.14. It's pi boxes big. So how do I write that as a formula? It's something got to do with the area of one of these boxes. So in this case, it was the radius times the radius, so it's going to be radius squared times pi. And that's the formula for area. Pi times radius squared, written pi or squared. So I'll write that out. So that will usually be 3.14 times the radius squared, which is the radius times the radius. That is how we get the area of a circle. So you never actually need to do this box thing that I did. I was just showing you. It's very interesting where it came from. That's why pi, once again, is so important. It's weird, but it works. Every circle in the world follows this pi number. Now, let's go back to this question without drawing the boxes and just knowing our formula. So it's 10 centimeters of radius. Remember, radius is the distance from the center to the outside of a circle. So the area of this circle is pi times 10 squared, pi times the radius squared. And that gives 100 times pi. Now, if they ask you to leave it in terms of pi, that's it, job done. It's in terms of pi. But if they ask you to work it out as a decimal, you've got to get your calculator out. 100 times 3.1. Okay, and that gives you 314.15, and so on, so on, so on, so on. So we round it off to the nearest whole number. It'd be just 314 centimeters squared. Remarkable. Okay, let's look at this second example. So this is a diameter that have 12 centimeters. So I just jump straight into my area formula. No, I have to use the radius in this one. Must use the radius. So if they give me the diameter, I use my logical brain and say, well, the diameter is twice as long as the radius. So radius, half that. So that's actually 6 centimeters radius, which is the number I use. Okay, so the area of this one is pi times 6 squared, which gives me 6 times 6, 36 pi, and then using my calculator, this one's not as easy to multiply. I do 36 multiplied by, well, there's actually a pi button on your calculator. You might be able to find it, but in most calculators, it's second function and this 10 by 10 to the power of something, but if you second function that, you can see pi. So I've actually put pi onto the calculator, and it's just down here on mine, but if it's not on yours, just use 3.14. So I'm going to use 3.14 if I want to use pi. So 36 times 3.14, the decimal 113.04 centimeters squared for an area. So these two circle areas, 113.04 centimeters squared, 314 centimeters squared. I want to round this one off, 113 centimeters squared. Of course, rounding makes my answer a little bit less accurate, doesn't it? But sometimes in real life we use rounded answers because they're more usable numbers, such as 113. Okay, so it's area of a circle. If you have any questions, do let me know on area or circumference. All right, good luck.